Hello. Okay, so we're looking at page 6 of our guide notes. And you should have, before this point, looked at the slides and filled in items from the slides into your notes. And now we're going to do the practice problems. We're going to talk about the important points and the practice problems. Okay, so first thing that we talked about was the how can we distinguish between accuracy and precision? Because a lot of the times we use those terms interchangeably, but they actually are different from one another. Okay, so here's how I think of accuracy. Accuracy is how close our measured or experimental value is to a known value. So if we know, and it's been recorded, we know that water has density of 1.0 grams per milliliter, and then we figure that out experimentally and we measure it, and we get 1.1, and then we do it again, and we get 2.5. Well, the 1.1 is far more accurate than the 2.5. Now, precision, on the other hand, precision more relates to an instrument. And meaning, if I have an instrument like a scale or a ruler, and I'm measuring the same object over and over again, are those values that I'm getting from that tool relatively the same, or are they quite different from one another? Because if the values are really close, then that would be a precise instrument. But if we're getting a wide range of answers from the tool, then it's a not very precise instrument. Let's look at this example here in our notes. We have dartboards with darts. Now the known value, what we're trying to achieve, is the bullseye. So see how this group of darts, they are right in the center on the bullseye. So I would call that accurate. And then these darts or data points are also really close together, so I'd also say they're precise. Now here, our darts are precise because they're all very close together, but they're not accurate because they're awfully far away from the known value or what they were trying to measure and achieve. Here you can see that the data points, they're all spread out, so it's not very precise. But if we look at the average of all of that data, it's pretty much the center of the board, and so it would be accurate, but not precise. Now, last value here, when we look at this set of data, it's spread out, it's not the same, so it's not very precise, and it is not close to the bullseye, so I wouldn't call it accurate either. Now, I drew a picture of a centimeter ruler, and I want to talk to you about certain and estimated digits. The more digits that a tool can give us, the more precise it is. So let's see how precise this ruler is when we're measuring this object. Now, certain digits are digits that it is clearly and accurately past a calibration point. Okay? So when I look at this object, I know with certainty it's past this 1 calibration mark. And I know with certainty that it's past the 2 calibration mark. But now I'm in between calibration marks, so I'm no longer certain at this point. So I was certain that the object is 2 centimeters, but now I'm going to make an estimation between the smallest calibration marks, and I'm going to say that's halfway in between, so I'd say that's 2.5 centimeters. Okay. Do you see how it would be unreasonable for me to estimate that that is 2.5 0.52 centimeters. The human eye can look at tenths in between smallest calibration marks, but then past that into the 100ths, we can't see that. We cannot even somewhat accurately or precisely make that determination. Okay, so there is our certain value, and there is our estimated value, and for this tool, we wouldn't have anything more than that. We can either have measured numbers or exact numbers. Measured numbers are ones that we receive from measurements or from experimentation. Okay? There's a degree of uncertainty to them. But exact numbers don't hold that uncertainty. Think of it this way. If I have 5 eggs, then I don't have the possibility of having 5.1 or 5.2 eggs. We don't have 0.1 or 0.2 of an egg, and so it's an exact number. Same thing with ratios. There's 12 inches in 1 foot, and that's exact. We don't possibly have 12.1 inches in 1 foot. Now you have a couple good measuring techniques. First, when you are measuring volumes, so liquids, volumes of liquids, you're going to see that it has a meniscus, okay? And so when you're measuring this, you should be measuring from the bottom of the meniscus, not the top of the meniscus. And on top of that, if you look down to make your measurements or up, you're going to have a parallax error. So it's very important that you look at these measurements from eye level. Now let's look at these 2 rulers here. And we're going to measure this object. And that's what I did earlier. I looked at this using this ruler, I'm going to say centimeter ruler, and I said I am certain that this object is past 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I am certain that it is past 11. Now I'm going to make an estimation in between the smallest calibration marks, and I estimate that object is 11.8. But that's the estimation. That holds some degree of uncertainty. Okay? Now here, I am certain I'm past 11. I'm certain I'm past 11.5. Maybe I need a piece of paper to look at my ruler a little closer. So 0.5, 0.6. Oh, but I didn't make it to 0.7. So I have my 0.6, and I would estimate that a tenth in between the smallest calibration marks, I'd say this is 11.65. So that's now my estimated. This was my estimated here. Now that's my estimated there. So take a moment, ask yourself, which ruler is going to be more precise? Typically, not always, but typically if your instrument is precise, it's also accurate. Okay, we talked about certain and uncertain digits. If we are certain that an object is past a calibration mark or at a calibration mark, like here, we're certain we're past 2, and 2.1, 2, 3, 4, 5, 6, 7, okay, 7, and we're certain of that. We're certain we're past the 0.7, and now we're going to make an estimation between those smallest calibrations, and I think that's 8/10 of the way to the next calibration. So our measured value would be 2.78. There's my certain, okay? And then that one digit. And that's always how it's going to be. Only one digit at the end is your uncertain or your estimated. All right, now I want you to hit pause, take a moment, go find an object in your house, take a ruler, and start making measurements. And tell me, based off of the tool you have and the ruler, I want you to first write down the measurement and then tell me which values are precise and we're certain of, and which one, or the last value, is the estimated one, okay, and how you know that. So that's what I want you to do here. Some of these are like partner things, so let's focus on that prompt here. Find an object, measure it, tell us the measurement, and how you know some are certain and some are uncertain. All right, now we're going to, in the next video, talk about significant figures. And so continue on with the next one after you finish that activity.